Hi all, and welcome to my M1 Lightning presentation on types of class relationships, specifically used relationships in Java. Let's get started. So what are some types of class relationships? Well, typically we divide class relationships into two different types, is-a relationships and has-a relationships. In this talk, I'm mostly going to be focusing on has-a relationships, but it's good to know when is-a relationship is, just because you need something to compare it against. Is-a relationships typically is inheritance. I'm sure you all are very familiar with the concept of inheritance. Essentially, a coffee table is a table. In essence, a coffee table is a specialization of table, or vice versa. A table is a generalization of a coffee table. In terms of has-a relationships, there's two main types that I covered. Association, where a table has a coffee, and aggregation, where a table has legs. The difference between these two is typically in association, the coffee is not really part of the table, but it's associated with the table. Like you put the coffee on the table, but it's not like embedded in the table. And in terms of aggregation, a table has legs because the legs are part of the table itself. Now, of course, not all tables do have legs, but many do, and if a table does have legs, it's part of the table itself. There's also other types of has-a relationships called composition. I didn't mention this here, but it's essentially a stricter form of aggregation where the object could not exist without its something. So in this case, if all tables had legs, then this would be an example of composition. And of course, these definitions did vary a lot in my research, so take these definitions with a grain of salt, please. So just a quick example for inheritance is a sample of simple inheritance where a book extends textbook and picture book, or I guess in this case the other way around. In this case we have a main class book, and then picture book extends book and textbook extends book. Very simple inheritance. In terms of association, I'm going to present an example where we have a table with a coffee on it. Here's a little diagram in case you need it. Yeah. In my example for association, I create a table class with a property of type coffee. Coffee is another class that I implemented over here, and it's just a very simple class, has a date made and coffee type and a nice toString, and that's implemented over here because we have the coffee property of this, and it's just being used in this separate class. This is an example of the class relationship of association, since coffee is associated with the table but not really part of it. In this case, it's on top of the table, not really embedded into the table. I don't know how many people have coffee cups embedded into their tables. For the has-a relationship of aggregation, I'm going to be presenting an example where we have a table with legs and also surface finish, but that's not included in this diagram. We have a little diagram on the right, and let's take a look at the example. In my example for aggregation, I create a table class. This class has two nested classes called surface finish and leg. In this case, I implemented these subclasses as an array of leg and just a single surface finish. In the constructor, you just get these variables to go in, and then it just has a really nice toString method. If you want to test out this code, I also have a testing little tester over here. And this is an example of aggregation, since these two are both part of the table and they're encapsulated inside the table class. So why should you be using these types of has-a relationships? Well, for association, we use them all the time. They simplify code, they improve readability. It's easier to tell what's going on because you are literally referencing, for example, a pineapple rather than the properties of pineapple. So it encapsulates all the information you need into one nice little package and makes it much better, easier to maintain too. For aggregation, these are usually used for helper classes, as we saw. This makes the class relations much more readable, especially if you do this in a nested class, simply because the class is there already and it's pretty obvious where it is. It's also important to note that while I didn't implement this, you can also access the encapsulating classes variables in an inner class. So that simplifies code a little bit if you just want to be lazy and implement something really quick. So thank you. Here's a couple sources that I used to create this talk, and thank you for your time.